So first of all, I would like to thank for the nomination and the invitations. And 2 weeks earlier, I received an invitation, and I feel really surprised at why I'm selected. Because I just joined UST as a faculty member just last year, and the total number of students that I've taught so far in my courses is less than the number of students in this room. So I'm really surprised that I'm selected and nominated. So thank you. I have been thinking about why, given that I'm just on UST since last July, why I'm nominated by students. Or through what channel the students know about me. And in one night, when I was solving my own math problem, and I want to find out a paper that was written by myself earlier this year. And I cannot find it in my computer, and what I do is to try to Google, and I type my name in Google and try to find out my paper. And instead of finding my paper, I found this. So sorry for some of you who don't read Chinese. So what I mean here is, is the Frederick Fong in the math department is an A0 guy. And so sorry if you don't know the definition of A0. And if you don't know that, then one thing you may do is maybe you can see the definition from, for example, Hong Kong Golden or etc. So maybe. That may be the reason that I'm the students know me about what is from the courses that I taught. It's through this channel rather than the courses that I taught. So maybe I should also thank you, the admin, for this UST secret groups maybe. Okay? But the thing that I want to talk about has nothing to do with this post. I'm not going to give any response to this post today. But instead, I'm going to talk about some more serious talking about some math. So a title I made was a mathematical theorem that turns me on. And the reason I come up with this title is when I received my invitation email about 2 weeks ago, I think. I have no idea what to talk about. And then so I just randomly write out a title. There's a very universal title, so that I have time, 2 weeks or so, to think about what I want to talk. So that's why I come up with this title. Well, I said it's something that turned me on, but sorry, it's about math, so probably it's something that turned you off. Okay? So it's compared with all the other excellent talks that is given by the other colleagues, is relatively more academic than the talks you listen so far. So what I want to talk about is something that I carefully pick. That is a theorem or a theory that is kind of accessible to general audience, and is somewhat meaningful to talk about. Okay? And I look at what I have learned in undergraduate, and it's very difficult to find one such a theorem. But this one theorem that I learned from Professor Keen Lee in the math department, that I find is really suitable for this talk. So let's consider one problem. So let's say I have the Hong Kong island here, and then I put a map inside Hong Kong island. Put a map of Hong Kong Island inside Hong Kong Island. So I have a map here. So what is a map is about is, let's say this point here is representing this point in the island, and also maybe this point here is representing this actual point in the island. Then, so there's one theorem that can conclude the following thing, that is, you can always find a point on the map that is directly above the point that it represents. So that's something I feel really excited about. So why I'm feeling excited about is something I want to talk about that in this sharing. And So let me repeat what I mean is you can always find a point somewhere, no matter how you orient this map, you can always find such a point so that it's directly above the actual point that it represents. So for example, if I put a map like this, you can find a point roughly around here that's representing the actual, it's directly above the point that it represents. So it seems like it's a geographic problem rather than a map problem. But let me formulate this problem in a more mathematical way. So let's say this is the Hong Kong island, and then you have a map inside Hong Kong island. So, so if I pick a point somewhere in the Hong Kong soil, and let's say I label it to be P, then it's represented around like this point on the map, right? So I call this the f of P. Okay. So think of this as some kind of function that takes this point to this point. So if I have another point like here, and so it's represented by this point on this map, so I call it f of q. Okay. So think of f is some kind of transformation that take this point to another point like this. Okay. So what is the problem is about this? I want to find a point on the map that is exactly above the point that you represent. So what we want to find is a point x on the Hong Kong soil that is exactly equal to the f of x. So that is the key idea of solving that problem, is to show that this equation f(x) equals x has a solution. So well, the full proof is not something I want to talk about. Well, I'm not supposed to talk about proof in the 10-minute sharing. Although, in my opinion, writing proof is much more enjoyable than writing lab reports. But I don't want to do that right now. But the key idea here is, let's say I have a picture like this is the Hong Kong island, and then I have a map of Hong Kong island. And then we got, right now, this is the Hong Kong island soil, the actual Hong Kong island. And then I look at where this map is located in this map. Okay? So it's a map inside this map. Okay? And I just repeat over again. And then you can see that the map is shrinking and shrinking, and then at the end it will somehow approach to a point. And this is the point that we are talking about. Okay? This is the point that we are looking for. Okay? And so that is somewhat the upshot of the argument why such a point exists. Okay, so of course I cannot give you the full detail of the proof here, but this is the key idea. Okay. So first of all, why do we care about this kind of toy or the problems? So there's the point I want to make right today is. Well, even though it seems to be a very purely mathematical problem, it doesn't make any practical applications. But in fact, this mapping problem, the theory behind this kind of mapping problem, is actually have far-reaching implication to other fields outside mathematics. For example, one of the implication is on game theory, but this I just learned that there's one game theory expert sitting inside this room, so I removed some of the slides. But what I want to say is, because I'm not an expert in this area, but what I want to say here is, the theory behind game theory, the Nash equilibrium, is actually making use of the fixed point theory that I just showed you in the map problem. So that's one thing. So and then the next two slides are removed. And so another thing that is related to what I'm talking about in the map problem is differential equations. 2, 5, 2, 3, 5, 5, 1. Okay? Map 2, 3, 5, 1. Okay? And so let's say so how is it related to the map problem? So let's say I give you an equation like this, and I don't recommend you to try to solve it by hand, because even if you plug it in Mathematica, it will take maybe 1 hour to solve it. So So one rule of thumb, if you put an equation in mathematics, if it takes like 10 minutes to solve it, then you shouldn't solve it by hand. Okay? And so I'm not going to urge you to solve it, the equation, but what I want to talk about here is actually solving this kind of equation has something to do with the fixed point theory that I just mentioned in the math problem. So let's do something with this equation. So let's say I integrate both sides on this equation by dx, and then the left-hand side, of course, give you y. Well, I wouldn't talk about this if I were a professor in Chinese U or Hong Kong U, because most of you should know about math. Yeah? Okay. So let's say I integrate both sides. So the right-hand side, so the left-hand side becomes just y, and then the right-hand side becomes some stuff like this, an integral like this. So I view this integral as some kind of function where the y is the input, and then you input the y into the integral. So that's the y is considered to be input on the right hand side, and then you regard that this y is input, and the stuff, the integral, the log, and the sine is the representing the function. So what we are looking for right now is to solve the equation f of the y equals to y is again the fixed point problem, just like the math problem that we mentioned. In the math problem, we want to solve f(x) equals x, but now it's solving for f of y equals to y. So, so what is the take-home message? So, well, sorry for talking too much about the academic stuff, but my take-home message is Fong. So given that you have seen that you have a math problem, you have a natural equilibrium, and then you have right now the differential equations, and it seems like all these three are totally unrelated objects, totally unrelated stuff, but they're connected by one single theory, this fixed point theory. And so my take-home message is the following. So when you're young, just like you guys right now, when you see two like really distinct phenomena, try to be more imaginative and try to be more creative and think out of the box. Maybe there's some connection between the two unrelated facts, and that sometimes will give you some breakthrough, solving just by some real simple observation, just like the math problem. And so maybe in someday, so some people, well, especially local people, they worry about like graduate with ACO status, and maybe the ACO graduate work here has something to do with this. Okay? You never know. Okay? So okay, so maybe. Thank you.